Hi, now we are going to discuss a regression line as a regression function and some probabilistic aspect of regression line. Suppose we have a value, only values y's. Suppose we have only y values, that is y1, y2, yn. And if we want to understand how the distribution of y behaves, so probably what we will do, we will try to figure out the frequency distribution of y. So what we will do, we will create some beans like this, and then each bean, how many samples we see, and that will be our frequency of that bean, and we generally draw a histogram out of that bean. And this histogram gives us some sense of the distribution of the y. But if you look into the carefully, generally when we draw the histogram, we generally don't draw frequency on the y-axis, rather we draw density. How we draw the density? Generally what happens, we first draw the relative frequency. That means we calculate the how many, first we can, in each beans we have the frequencies. So we have the data, say y from y1 to y2, how many in this bean, how many y values are there. So frequency, you can compute frequency 1 from y2 to y3. You can have how many frequencies are there. In this way you can have yk minus 1 to yk. In this group you have fk, and total number of samples you have n. Now what you can do is, we generally, instead of drawing the frequency, you can always draw the relative frequency, which is essentially f1 by n, f2 by n, fk by n, and if you sum them up, it should be exactly equal to 1. Now what we do generally, instead of so we can call, so let us write it a little bit carefully. So we have the beans here. Beans are like from, so this could be y1, this could be y2, this could be y3, in this way. So y1 to y2, how many frequency, how many samples are there, and relative frequency is essentially f1 by n, which is r1. Then y2 to y3 will be f2, and relative frequency of this will be r2, which is f2 by n, and then yk minus 1 to yk, which will have k many samples. Total n samples are there in the data set, and we have fk by n, which is rk. So if I sum them up, all the relative frequency, it will give me 1. Now we will define density. essentially density is R1 by delta 1, R2 by delta 2, in this way Rk by delta k. Now what is delta I? Delta I is basically yi minus yi plus 1. So this beam width, so delta is the beam width. So delta is the beam width. So if I have this, let me take a different color. So this is the beam width. So what we are doing, if we divide the relative frequency by the bandwidth, then we get density, and that is what we plot here on the y-axis. So the advantage is, in this case, we get the area of the box is the relative frequency itself. So the total area under the all boxes will be essentially 1. So in the histogram, the total area represents the probability idea of probability. Now this is for the univariate case. What happens if I have two continuous variables, say x and y? Well, what generally we do is, instead of 1, generally we plot x on the x-axis and y on the y-axis. And how the data will look like? So x and y, and maybe some id variable will be there. So 1, 2, 3 up to n. So suppose I have n variables. So I have x1, y1, x2, y2, x3, y3. In this way, xn, yn. Now this x1, y1, I will take this tuple and I will try to plot them somewhere here. Then x2, y2, I will take them and I will try to plot them somewhere here. Then x3, y3, I will try to plot them here. Maybe x4, y4 here. So in this way, we will try to plot them on the Cartesian product. Suppose this is the data that we have, right? Now the question is, we can, if we just want to get the distribution of x, then what we will do, we will just ignore the y values and we will just create the beams and see how many points are there in each of these beams. So each of these beams, how many points are there, and based on that we will create a histogram. Similarly, if I am interested in, so this will give me some idea about how the distribution of x behaves. Similarly, if I am interested in the y-axis and how the distribution of y behaves, what I will do, I will create bunch of beams and I will see how many points falls in these beams, and then I will just create the frequency density, relative frequency density for each of these beams, and I will draw the histogram of the y, and that will give me how the distribution of y behaves. Now the question is, what is the joint distribution of x and y? How x and y behaves together? So what we can do, we can just create this bunch of joint beams, and now these joint beams are not anymore beams, they are almost like a boxes. So I'm creating now a bunch of boxes, and each of these, what we will look for in each of these boxes, which points, how many points are there. So these points are there, and basically we will count in each of these boxes how the points are there. Now what we can do, so essentially how it will look. So we will try to draw some kind of a 3D picture. So our points are, so this is my x, this is my y, and suppose that is how the points are. So now for x, we have beams, for y we have a beams, and in this beam how many points are there. Based on that we will draw 3D bar on third axis. Now so 3-dimension histogram will be created. A 3-dimension histogram will give us the idea how joint distribution of x and y, and that means that here in this case, so when we were doing, say, look into this one, so area of the box under the curve was, so area probability was area under the curve, but in the joint distribution, now the volume of the building, we can think of as a building, the volume of the building is our joint probability of x and y to be in that box. So we will continue on this and in the next video.